Now that we have the part made, we can go to the manufacturing space and we'll start the first of three setups. We'll be machining this backside first. So I'm going to come up to Setup, New Setup, and we want to orient our axes first. So it looks like our Z is oriented correctly. However, it's going down below the part. And our Y is inverted from the mini mill. I'm going to select this orientation tab and the XY axes. Now all I really need to do is flip the Y axis, and this is going to be reflective of what we have in the machine. The long side of our machine, so coming across the vise is going to be the X axis. Coming back and forth this direction is the Y axis, and then up vertically up and down, of course, is the Z axis. We'll be clamping our material in the vise, and we'll be setting our touch-off stock point to the bottom of the material. It's the most accurate location that we have. I'm going to go ahead and minimize this. And so we have our XYZ oriented correctly. Now we just need to tell it where the stock point is. So I'm going to come over to the stock point, select the lower corner. And now let's take a look at our rough stock size. And that's going to be the size, the true size of this rectangular blank that we put in the machine. And so instead of a relative size, I'm going to give it a fixed size. And I'll start with the Z. So our Z material rough stock size is 0.375, 3/8 of an inch. And we do want to be on center because we want to have a little bit of material left when we flip this part over to mill this side as well. Additionally, metal case hardens on the outside, and if you imbalance it too much, will warp. So we want to remove equal parts of material on both sides. The stock blanks that we have pre-prepared are 5 inches, and the size of the rough material is 1.75. So we can leave all of those default settings alone. And okay. So now we can apply some tool paths that we have it set up. I'm going to rename this setup to Operation 1 back face. And now I will start to select some tool paths. Generally, we'll start with a facing operation. And we're going to use the same tool on all these operations to sort of simplify. So we'll select tool. And I'm going to come down to this minimal aluminum tools. And I'm going to select the 1/2 inch end mill. It's this with the radius, a 1/32 radius on the corner. I'm going to select that. And I'm going to select OK. That will generate a facing operation. I'm going to go ahead and edit this by right-clicking on it, edit it. And instead of doing this all in a single pass, I'm going to use this multiple depths and just remove a 32nd of an inch per pass. And that's going to create a final pass that gives us like a little bit cleaner surface. Next, I want to mill away a lot of the meat on here, and the depth that I'm going to mill it away to is the difference between this top of the vise and this parallel that our part will be sitting on, and that's currently it's 0.1 of an inch, so 1/1000th of an inch or 1/100th of an inch, and I'm going to offset it by 0.125, just a little bit above that. So I'm going to come to adaptive clearing, and I'm going to retain the same tool. So now I just need to select this profile. I'll go ahead and select this interior profile as well. And then this heights tab, I'll scroll down to bottom height, And rather than selected contours, I'm going to use stock bottom, and we'll give this a value of 0.125. Okay. And so that's going to mill away all the way up to 1/8 of an inch above the bottom of the material, and on the interior of this part as well. Going to then do a boring operation to clear this out. So we'll select 2D bore, and same tool. The tool geometry going to use is this interior geometry. And this time I want to make sure I bore all the way through. Now that the bit that I selected has a 30-second radius on the tip of it, so I'm going to protrude beyond the hole bottom by a little more than a 30-second. So it'll be minus 0.04. A 30-second of an inch is 0.03, I think 125. And I will select, this is climb cut. I will select OK. And we can see if we look at the preview here that it's protruding beyond the hole. Now I'm going to go ahead and select a 2D contour operation. This is to clean up the outside. When we had done the adaptive clearing, it left an offset amount on the material. So we're going to clean that up now. Again, same tool. I'm going to select the profile that I want. This is the top profile. I'll come to my heights tab again, select the stock bottom, and we come the same amount upwards. So it's 0.125. Okay. So what I was referring to on this adaptive clearing is, I'm going to go back, edit. If we look at the passes, the default is that it leaves 0.02 inch on the material for a later to be like a cleaned up operation. We have the option for radial and axial. We really don't need this the axial stock to leave. We can go all the way down. So I'm going to zero this out. Okay. So now if we do a preview, select preview and then play, we can start to see, I have stock on, toolpath off. We'll start to see what operations are happening here. So we've bored this out. Now we have a final cleanup. All we really have left to do is to drill these holes and maybe do a light chamfer on the edge here. So I'm going to exit simulation. I'm going to select a drilling option or drilling toolpath, and we will change tools now. This will be aluminum tools, and it's going to be this tool number 9, number 40 drill. Let's select that. In the geometry section, hole faces, underneath that, I'm going to select same diameter option. And I'm going to delete this containment boundary. I'm going to come back here to select hole faces, select it, and now it selects all of the holes. We do want to penetrate below the hole, and in the preview you can see it that the drill bit has a pointed tip. I think it's a 60-degree angle. So we want to go beyond that pointed tip to where we're clearing it into this fully round section. So I'm going to come to the heights adjustment tab. So on the bottom, it has hole bottom, offset, and then it has this drill tip through bottom. So I'm going to select that option, and I'm going to give it a pretty high value, like 0.1. And that's going to go down and clear that out completely. Okay. So now all that's left is we'll use a chamfer bit to soften this interior and exterior edge so it's not sharp to the touch. I'm going to select a 2D contour. And to use the chamfer function, when I select a tool, I just need to select a designated chamfering tool. So I will select this 60-degree insert chamfer. Okay. And I'm going to select this interior and this exterior profiles. And over in passes, the camphor amount, it's going to be a very small amount, 0.01. We can do a 0.01 tip offset as well. Okay. Well, we have operation 1 done. We can move on to creating and milling the soft jaws. Soft jaws are aluminum jaws that are fixed to the vise that will allow us to cut into them so that we can grab this odd shaped part. And here's what it looks like in the vise. We'll begin by going up to setup, and we are going to create a manufacturing model. Then right click on the manufacturing model and edit. So we'll start by creating a sketch to reflect our soft jaw geometry. I'm going to rotate this view upwards, select this top plane, and we'll be machining this from this view down. We'll start with a couple of rectangles to represent our soft jaw. So R on the keyboard. I'm going to select this 3-point rectangle tab and just sketch something close. And I'm going to start constraining this rectangle. These lines will be collinear. These lines will be collinear. And D on the keyboard for dimension, I'm going to dimension this. These soft jaws we have are exactly 1 inch by 6 inches. And I'm going to make this soft jaw collinear with this edge. We'll go ahead and give it a dimension from that point to that point. We'll give it 1 inch. And I want this to be equal, or these two are identical and equal. And we want the spacing here to be just a little more than halfway. So I'm going to give it a dimension between these faces of about 0.75. And then we can exit the sketch and we will extrude this out to give us some solid geometry. So E on the keyboard for extrude. I'll select the two rectangular faces. And I want to go not from the standard profile plane, but from the bottom of our part. And we're going to offset up the distance we want. So it's going to be 0.125. And then we'll give it the distance of the soft jaws, which is 2 inches. So the default is cut. I'm going to change this to new body. Okay. So now we can use the combine tool to cut away the interference here. So I'm going to select what I want to cut. I'm going to select the tool, keep tools. Okay. I'm going to go ahead and hide this body. And this, we can leave this in here, but it's much more difficult to machine this in there. So I'm going to go ahead and delete it by selecting the faces, like Control Select, and then delete. That just leaves us with this little pocket in here. It'll be much easier to machine. It'll be easier to get our part in and out of there. So the last thing we need to do is distance these parts the same distance that we're going to use on the machine. So when we machine these, the vise needs to be under load. And we can't have them pushed tight together or it'll cut into this face as well. So we need to have a little gap in there. And I'm using a 1, 2, 3 block. So this is a block that's precisely ground to 2 inches by 1 inch by 3 inch. And we'll be using the 2-inch section under load. Let's see, I'm going to move this over. So I'm going to use the move command. So it's M on the keyboard or this arrow thingy thing up here. And I will select this first part to move. I'm going to use this point-to-point feature. And we want to go from this point to this point. Now they're tight together. OK. I'm going to use move again. M on the keyboard. But this time I'm going to select this free move feature, and this right-hand edge, start to drag this away. So we'll move this exactly 2 inches. Okay. And now we're ready to start adding some toolpaths. So I'm going to finish edit, roll this up here, and I'm going to create a new setup. New setup. And I will give this model orientation, like we can see that the Z is coming out of the material, so that's good. So we'll use this X and Y. And I will select the first axis as the X axis. And we have our orientation is good there. The easiest place within this model to touch off from is going to be this face, the top here, and this outside edge. So that will be this point here, this corner point. So I'm going to select this, instead of stock origin point, I'm going to select this selected point and come here and select that corner. The last thing to do is to define the stock size. So I'm going to go to stock, and the relative size is selected. So I'm going to select 0, 0. And you can see we still have some stock left over. So that indicates that it's picking up our compass body, which will not actually be in there. So I'm going to come over here to model, select model, and select these two soft jaws. So now our material window is shrunk down to the size of the soft jaws. Okay. So now we just need some geometry or some toolpath to cut the geometry. So I'm going to come up to 2D, and we'll start with this adaptive clearing. I'm going to select the tool. It'll be the same tool that we've been using. So it's this 1/2 inch tool number 3, Harvey end mill. Select the pocket to machine. And in the passes, the stock to leave, we can go ahead and leave the radial stock, but the axial stock will just 0 that out. Okay. So we had left 0.02 inches of radial material on this edge. So we're going to come back with a cleanup operation, a 2D contour, and we will machine this edge here. And okay. Now the tool we're using has on the edge of the tool a 1/32 of an inch radius. So there'll be a little bit of radius left inside this corner, which if we had a sharp point or a sharp cornered part would interfere. And that's part of why we used in the previous setup this final 2D contour, chamfering contour. It'll chamfer away that edge and allow it to mate up tightly to this face here. So now we can go ahead and create the final setup and final toolpaths. I'm going to come up to setup, new setup, and I will start by defining the fixture. So I'm going to select these two as our fixture elements, and then I will select the model as our compass. And then I'll come up to the work coordinate system and define our x-axis. And we want our start point, our origin point, to be identical to the previous setup when we created the soft jaws. So I'm going to come up to origin and selected point and select this point that mimics what we had before. Now we'll define the stock. So by default, it's from previous. That's why it looks kind of odd at the moment. We're going to use a fixed size box. And I'll start with the Z. So on the Z, our thickness was 0.375, 3/8 of an inch. And then we removed about a 32nd of an inch. So it's 0.03125. And our X and our Y depth, like our width and length, are still the same as they were before. Let's take a look at where our stock lies relative to this part. So Right now, by default, it's on center. We'll need to change that to be offset in one direction. So we'll give this a 0 value, and now all of our stock is on the top of the material. So I'm good there. Okay. So we can copy and paste some of the tool paths that we plan on using again. So I'm going to use the facing operation from operation 1 and the contour operation. So I'm going to control select it, and then control C, select my setup, control V, get an error warning, but it's okay. And I'm just going to right click, edit, and okay. And it should invert the regenerate and invert on top of the profile. I'm going to come down to contour. I'm going to right click, edit. And in the geometry selection, there's no geometry selected. So I'm going to reselect this interior and okay. Now we still need some tool paths to mill away this extra area. So on here, it's going to be milling away this rectangle. So I'm going to use a 3D adaptive clearing. You go back and select our typical 1/2 inch end mill. And the depth that I want to go to is not all the way down. I'm just going to go down to this top surface. So I'm going to come to heights. And rather than model bottom, I'm going to use this selection tool. And I'm going to zoom in and select a node that represents that top face. Select OK. Let's see how that looks. So you can see that it's going into this hole. If we don't want it to do that, we can go and create a new manufacturing model and fill that hole in. But the hole's already been cut, and it shouldn't really affect too much of the. It shouldn't touch these interior sides if our setup is good and sound. So that looks pretty good. Let me go back in really quickly, and I'm going to check this stock to leave. So again, we don't really need the axial stock. I take that back. We do want the axial and radial stock on there. We're going to come back and clean that up. So next thing I'll do is come down to this 3D, and I'm going to select this flat tool. And I believe I can just okay this, and it's going to recognize the flats. It sees the flats and it mills them to the final size. I'm just going to go back, double check that there's no stock to leave left on there, and it looks to be good. So I'm going to okay that. And then 3D, and we're going to use this blend tool. So it's going to blend in this face here, and same tool. So the driving face is this face, and the containment boundary is these two curves. Select OK. And that will mill clean that face. So we're still left with the adaptive left material along this edge here. So we still need to do a cleanup contour pass. So I'm going to select the 2D contour tool, come to my geometry. I'll select this lower profile. Now the depth of cut, from our previous operations, we've already cut into this upper face. So we're really just needing to clean off this outside edge. So I'm going to go the bottom height will be a selection, and it's going to be, again, this face selection here. And okay. So that should clean up this outside edge, and we are ready to go. The last thing to do is we want to relocate the order of operations of this chamfer contour. So I'm going to drag it down. And then it wants to regenerate this adaptive. So I'm going to select it and Control G. And we should be good to go. We should be good to run it on the machine.